slide at the moment. So if there's a bit of background noise, apology in advance. So, okay, thanks for inviting us. I'm representing the OME team. I've got probably 2 colleagues that managed to join as well. Things that I'm going to go through in practice in order to feel, I think, during the previous presentation, what PAIR is really well described, but output in practice is always quite a challenge for many people, and how it will look like. So IDR is I would say, public access, similar to the bioimage archive. It's free. It's free to deposit, and we're also very grateful to BI for providing all the storage, because IDR is running at EBI. IDR is based on Homero. I've seen a lot of presentation, some constraint, because IDR is read-only, you don't write to it. The main difference, I would say, between the bioimage archive and IDR is we host reference data sets. So this is data set that we deem of big value for the community. So we'll not host all the data that are published, but if let's say if there's publication around a new organism, that will be hosted. And we also curate heavily. So I think my colleague Francis Wong is attending today. So she's lead all the curation effort. So this is an important part, because curation is can require a lot of back and forth with the submitter. And what we want to enable is reanalysis and reaccess to the data. So this is just like we say, public access, and we can see there's different access from all around the world. So there are different IP that have accessed the IDR in the past year or so. So in practice, similar to what Teresa was indicating, you want to import your data. Image data is one thing, and you have also, by metadata, I indicate analytical result or extra data that can be associated to the publication. We validate that step, and then there's a annotation phase where we come with linking to ontological elements. So we have template for that as well, but and when when that is validated, the data gets published. Often we got the question, how long does it take for publication? I would say, is how long is a piece of string? It really depends how good you have been with your data from day one. And as we have seen, in many cases, images can be composed of multiple files. They delete a file because it's not useful. Well, the library that we use, bioformat, said the data are not complete, so we cannot accept. Very simple. So how does it look in practice? So in practice, we use Homero. So people familiar with Homero will see that. Sorry, I need to move things. So you'll have experimental data. We display biomolecular data annotation, and also analytical result. So all that, and we have all the modality that bioformat support that can be ingested into the system, including screening data. Okay. So how to become fair, as we've been introduced, Isabel and others have introduced that. So what does it mean in practice? Well, we have information about the author, you have references, publication, but you also need information like DOI for the data and licensing of the data. That is very important when people want to reuse your data. That is coming. We found that today. A colleague of mine says, "Not why do we put all that effort in putting metadata?" So that's with if you go to the YouTube channel of Beth Simini and Erin both from Harvard, I think they started to look at various tools, and they publish. There's a video around metadata around IDR that was just put it up a few days ago, and metadata is key there. And those are people doing analysis, not necessarily only looking at metadata as such. So people doing analysis need those metadata. That's the message, I would say. So IDR use several ontology when their data is submitted. So again, this is an important piece to add value, because we can then start linking various pieces of the puzzle together for data reuse. So when data how do we use it in IDR? So it's for linking the metadata together, linking to external resources, and after that, allowing us to having to query those data and start to ask scientific question. Can you find me images with gene X or compound Y, or review some publication when people, especially during the COVID phase, they there were a lot of data, and can we actually inspect the result? And if we do not have those metadata, it's very difficult to actually find this little coin or euro in this big jar of knowledge. Oh, I've tried to find the English say for that. Too late. Okay, so how does it look in terms of practice? So we link metadata. So there's phenotype information that we can link then due to the ontology, we can link it to the gene information. From the gene, this gene information, and then find other study related completely separate to what we're looking for. So that is very important when you try to look at data around, can I find related, when, especially when you want to do analysis. So to move. And you can see also the little logo in the corner associated to the phenotype, little symbol, which then allowed us to, can I get more, information around what does it mean? So we are now able to link all the pieces for someone not familiar with that term, ontological number, can find what it means in text, but that is hosted in separately from IDR. So how to access IDR data? So when you want to do work with it, so you can, as I said, access via the UI, but you also, in many cases, want to download the data. So you have either, you can use FTP access or Globus. And you can also, in some cases, I've not put that on the slide, but you can also do a standard for certain type format, like if they are composed of single TIFF or image, you can do like a wget or harvest just the data, just as one element, not necessarily the full study. You can use the API. So using the API is very convenient when you don't want to have all the data because as soon as you download a file, you will need to read it and have the reader to read that file. And that might not be the case when you do analysis. You might not have, for example, bioformat installed on the machine or on the cluster node to read the data, or when you want to use in a different environment that you have only Python, you don't have Java accessible. So that's and the Python library doesn't offer you that. So in that case, the accessing the data via the web API, via the API is much more practical, because you can then download the pixel and also only download the pixel you are interested in. And now what people have already mentioned quite a bit, and Teresa mentioned it already earlier, is we also have some data converted into OMISAR. And in our case, we try to push people to submit, to convert before submission. To answer Isabel's question. And what we are now start to look is data can be converted and hosting into IDR like other format, but also we've now work at solution where data have already put hosted in S3 somewhere. And when the publication become IDR, make a link to that storage elsewhere. So the data are not moving because they are too big. So that is a factor that we also need all to consider, as Teresa alluded earlier on in her presentation. Data are getting very big. That's mean moving data. If someone publish and they are in US and want to submit data in IDR or the bioimage archive, we have to consider how many days is, or if it's possible to move this data. Like some cell painting study, is moving the data again is not an option. So we have to find a way of making those data sets still findable and enhance those data set without being necessarily moving them. So of time, I'm just going to finish off with an example that is in IDR. So it's around multimodal data. So we're hosting imaging data, and alongside those images, we're also analytical results, so the little ROI on the image. And associated to each ROI following an established format as part of the nucleome, 4D nucleome project. So as part of the reusability, we need to use open format. So we use an open format to store some external metadata. And what is the advantage of doing that? Someone else completely outside of the IDR team has built what's called the nucleome browser. We can actually link genomics data and imaging data and visualize the two. So if you move over a part of the genome, you can have access to the image with this, where the little region of interest was drawn. I think to finish, those are the tips provided by Frances Wong as the curator, and I think they are very, very similar to what Teresa was indicating, is you need to start early and think of your data. I would agree, it's difficult to capture everything at the early doors, but the more you can capture, the better. And I would like to thank all the founders and all my colleagues that are pushing, as Teresa said earlier on, it's a team effort, and also all the community that always give us great feedback and submit file. Thank you.